through G.2. This is 2 questions from. I think most people thought about the tail end of 3G1, if not finished it already. So just one example to do, 2 questions to do from there. I will also go through this, which is a problem-solving question. It's popped up in every test for the past sort of 4 years, so you can expect something like this. This is quite similar to question 8 of the 3G.1 that you're doing at the moment. Maybe you're stuck on it, in which case this will help you. So let's get into here. Find the circle with equation here in expanded form. So expanded form means we're just going to fully expand it and bring everything to one side. That's all we have to do. So here we're just going to apply perfect square rules. I'm just going to do it in one go because my expectation is that we're quite competent at doing that now. So I've got x squared takes 6x plus 9 plus y squared plus 10y plus 25 equals 25. Okay? Then we're going to bring everything over to one side. And the technically correct order that we write it in is we're going to put x squared plus y squared, take 6x plus 10y, and then we've got plus 9 plus 25. And I said I want to move this number over the other side, so I'm going to subtract 25 from both sides as well. Okay? And then our statement's going to be x squared plus y squared, take 6x plus 10y plus 9. 25 and 25 will cancel. Right, so the reason we write it like this is because these two both have the same degree. They've got a degree of 2, so they're the leading terms. And then the next leading term is going to be x to the 1 and y to the 1. And then we have a constant at the end, and equal to 0. So that's it. That's 3G.2. Let's have a look at this problem solving. So we've got a pizza joint located at x is minus 3, y is positive 2. And they have a delivery radius of 4 grid units. Okay, so on the Cartesian plane, they're willing to travel 4 grid units in each direction, where each grid unit represents 3 kilometres. Now, for the purposes of these questions, just keep everything in terms of grid units, unless asked otherwise. So, write an inequality that dictates the region where pizza is delivered. So, if we're thinking of the equation of this circle, right, it's going to be x plus 3 squared plus y take 2 squared equal to, the radius is 4, so equal to 4 squared. Alright? And so they're only going to deliver to regions that are on that or inside of it. So we're going to say it has to satisfy this description. Less than or equal to, I'll put 16, I'll change it to 16. Alright? Okay, part B. What is the maximum distance that pizza can be delivered to? Well, we're told they're going to deliver within a radius of 4 grid units, where each grid unit is 3 kilometres. So the furthest they're going to travel is 12 kilometres. Alright? So that'll be our answer to B. Okay, there's not any working out involved there, it's just an intuitive response based on the information we're given. Part C. If Joe lives at minus 3 and 7, will he get delivery? This is as simple as substituting these coordinates into our inequality and seeing if it satisfies the statement. So I've got x is minus 3, I'm going to put that there, and y is 7, I'm going to put that there. So that was part A, this is part C. So I'm going to have minus 3 plus 3 squared plus 7 take 2 squared. Being less than or equal to 16. This is what we're checking to see if this is true. That's 0. And then here I've got 5 squared. And so I've got 25. Okay, now 25 is not less than 16, which means Joe is outside of the region that gets free delivery. Okay? Now a follow-up to that might be, how far away is he from getting free delivery? How far is it from getting free delivery? Well, we know the location of Joe's house is minus 3,7. So I might do this one up here. This can be part B. Joe's at minus 3,7. And the pizza joint is at minus 3,2. And so we might say, well, what's the distance between them? Okay, what's the distance between these 2 points? We can use distance formula. Distance is the square root of x2 take x1 squared, so minus 3 take minus 3 squared, plus y2 take y1 squared. Do 2 take 7 squared, and then square rooted. Again, here we've got minus 3 plus 3, that's 0. And here I've got 2 take 7, that's minus 5. So it's the square root of minus 5 squared. So it's the square root of 25. And it's 5. Okay, and I'm going to make a real easy connection here. So the distance between Joe's house and the pizza joint is 5 grid units. Okay, which means in terms of distance, it's 15 kilometres, because each grid unit is 3 kilometres. And the pizza place is willing to deliver up to 12 kilometres, which means Joe is 3 kilometres away from getting free delivery. Okay, that makes a fair bit of sense. And look, we can see this quite clearly. Look, the distance from x is minus 3, y is 7, to x is minus 3, y is 2. Think about this graphically, okay? If here's our Cartesian plane, here's x minus 3, here y is 2, and then we have minus 3 and 7. Okay, so they have the same x value, and the only value that's changed is y, and it's 5 units difference. So of course it's outside the region. So what does that involve? We've expressed an inequality. All right, the only thing we had to do is change that from an equals to a less than or equal to. That means it's including that region. And then the way we check if a point is going to satisfy the inequality is we just insert it into the inequality. Is it less than? No, it's not, which means he's not getting free delivery. If it is less than 16, then it means he is inside the region, he will get free delivery.
I thought he just didn't get delivery at all.
So, any questions?
Yeah, same.
No, so let's proceed. We can finish off 3G1, finish off 3G2. Tomorrow I'll just bring some revision for us, but we'll get straight into revision tomorrow.